All right, let's dive right in. Today, we're talking about the secret language that all computers speak, logical operators. Now, these might sound complicated, but they're actually super simple rules that let programs make decisions. And trust me, by the end of this, you'll see how they are the hidden engine behind pretty much all the cool tech we use every single day.
So, you ever stop and wonder about that? I mean, how does your email know something is junk? How does a self-driving car decide to brake? How does an AI know if its own prediction is any good? It all seems incredibly complex, doesn't it? Well, let's pull back the curtain.
Because here's the secret. Computers actually make decisions in a way that's, well, a lot like how we do. It all comes down to some really simple logical steps. In fact, you're using this exact kind of logic all the time and you probably don't even realize it.
Just think about a sentence like this. To go for that walk, two things have to be true. It can't just be sunny and cold, and it can't be warm and cloudy. It has to be both. This whole idea of combining conditions, well, that's exactly what we're talking about today. It's the absolute core of how computers think.
Okay, let's get into it. The amazing thing is, almost all of this really complicated decision-making can be broken down into just three basic ideas. Three. You could call them magic words that form the foundation of all programming and data science.
And here they are, logical operators. Put simply, they're just tools that help us work with things that can only be true or false. There's no in-between. Think of them like the grammar a computer uses to reason. They let it connect simple truths to arrive at a solid, logical conclusion.
So these are our three magic words, and, or, and not. And is the really strict one. Everything has to be true. Or is way more laid back. As long as one thing is true, you're good. And not, well, not is the simplest of all. It just flips the answer. Let's break them down one by one.
So let's start with and. I always think of this one as a strict gatekeeper. You know, it's got really high standards, and if you don't meet every single one of its demands, you are not getting past. Here's a perfect example from the real world. Imagine you need a student ID and a lab coat to get into a science lab. If you show up with just the ID but no coat, nope, you can't come in. What if you have the coat, but you forgot your ID? Sorry, still can't get in. You have to have both. That's the and rule in a nutshell.
Now let's see how this looks in actual code. We're going to set up two really simple variables. Let's just say A is true and B is false. We'll use these to test out our logic. Okay, so remember our strict gatekeeper? The AND operator will only give you a true if every single part of the statement is also true. If there's even one false anywhere in there, the gate just slams shut and the whole thing becomes false.
And look, this shows it perfectly. We asked the computer, hey, is A and B true? And the answer is a hard false. Why? Well, A is true, sure, but our gatekeeper sees that B is false, and that's an instant deal breaker. Both conditions were not met.
So why does this even matter? Well, in machine learning, this kind of check is happening all the time. A model might need to check if a piece of data is within a valid range and if it has the correct label. If both of those aren't true, that data gets tossed out to avoid messing up the results. It's a basic but super important quality check.
All right, on to our other two operators, or and not. Now, if and was that strict gatekeeper, these two are all about giving us a little more flexibility, a few more options.
Think about getting into a secure room. You might have a physical key, or you might know the digital passcode. The point is, you don't need both of them. Either one will get the job done. That's the OR rule. It gives you more than one way to get a true.
And that's pretty much the official rule. The OR operator is way more forgiving than AND. It just needs to find just one true condition, and the whole statement becomes true. The only way for OR to fail is if every single option you give it is false.
Okay, so let's grab our same variables. Remember, A is true and B is false. This time we ask, is A or B true? And we get true. Why? Because the computer sees that A is true and it basically stops looking. It's found at least one condition that works, and that's good enough.
And finally, we have the simplest operator of them all, not. This one doesn't combine things, it just flips them. The rule is simple. You can go outside to play as long as the statement "it is raining" is, well, not true.
Honestly, the best way to think of not is like a light switch. It takes whatever you give it and just flips it to the opposite. If something is true, not makes it false. If it's false, not makes it true. It's a simple reverser, but you'd be surprised how useful it is. So let's see it in action. What happens if we use not on our variable b, which we already know is false? Well, the result is true. The not operator just takes that false value and flips it right over.
Okay, this table here is basically a cheat sheet for everything we've just talked about. It's called a truth table. It just shows you every possible combination for A and B, and then tells you exactly what the result will be for and, or, and not. It's the complete rulebook, all in one place.
So we've gone over the individual rules, which is great. But the real magic, the real power, happens when we start chaining these things together. This is how you go from a simple check to building a system that can actually make some pretty smart, complex decisions.
Let's just walk through this example of checking an AI model. First, the system checks if the accuracy is over 90%. Yep, it is, so that's true. Next, it looks inside those parentheses. It asks, is the precision over 85%, or is this data point not an outlier? Well, in this case, both are true, so that whole section is definitely true. So what are we left with? A final check, true and true. And the result of that is, of course, true. The model is good to go.
And you see this kind of logic absolutely everywhere in machine learning. It's being used for things like data validation, filtering out garbage data, combining different rules about what the model should be looking for. Basically, it's doing all the heavy lifting and quality control behind the scenes.
So if there's one thing to take away, it's this. From the simplest little app on your phone to the most advanced AI on the planet, it all comes back to these three little words: and, or, and not. They are the absolute bedrock of digital intelligence. Which kind of leaves you with a fun question to think about. Now that you know the rules, what's the most complex decision you can build using just those three simple tools?